Okay, students, today I'll discuss acceleration for linear dynamics. That is, when a particle is moving on a linear path, it is not rotational, is there? So first, let me define acceleration. So acceleration of a particle, so it is the rate of change of velocity of a particle. So when mathematically we can write it is dv by dt, or this is your instantaneous acceleration is there. So at a particular time, more mathematically you can write limit delta t tends to 0, delta v by delta t. Right? So at a particular when the time interval is very small. So how to find out the acceleration of a particle? Sometimes people are thinking the direction in which the particle is moving, that is the direction of acceleration. No. See, all of you are physics student. Under this condition, what is the direction of this? So that will be the direction of A. So direction of delta V. Direction of delta V gives the direction of A. Direction of A. And one is known as average acceleration. One is known as average acceleration. So this is simply delta V by delta T. So we can say also Vf minus Vi upon delta T. So this is your average acceleration. This is your average acceleration. So this is your average acceleration. See, the limiting value of average acceleration is your what? Instantaneous acceleration. So in this case, A also can be written as dv by dt, and in 1D we can say A is equal to dv by dt, and this is d by dt of dx by dt. So under this condition, this is also you can say d2r by dt2 in general in 3D, and this is d2x by dt2 in 1D. So this is the acceleration. It is a vector quantity. So it is a vector quantity. Vector quantity. Its SI unit. Its SI unit is meter per second square. So rate, that is which to time how the velocity is changing, that is known as what? Acceleration is there. For example, suppose a particle is moving on a straight line. On a straight line having position x is equal to 3t square plus 2t plus 1. So find acceleration of the particle at, suppose t is equal to 2 seconds I want to. So see, since its position is changing with respect to time, so if you want to find out what is the acceleration of the particle at t is equal to 2 seconds, so just have to differentiate twice. So difference this twice is there. So this is 3t square plus 2t plus 1. Differentiate once, 60 plus 2, and again differentiate. So again differentiate with respect to time, get acceleration. So dv by dt, and this is 6 meter per second square. So this is constant is there. This is constant about that. Now, since A is dv by dt, you know velocity has two things. One is direction and one is magnitude, right? So sometimes if direction can change, then also the particle accelerated, and magnitude can change, then it is also accelerated. So this acceleration, the acceleration is of two types. One is tangential acceleration. This is tangential acceleration, and one is normal acceleration is there. One is normal acceleration. So generally AN, it has several names are there. It is also known as radial acceleration or centripetal acceleration or centripetal acceleration. So it has several names are there. So now I am going to discuss with it. Right? So this is the net acceleration, right? So this is the net acceleration. In this acceleration, there is also, it can be tangential acceleration, it can be normal acceleration. So now I am going to discuss with you what would be tangential acceleration and what would be normal acceleration is there, right? So tangential acceleration, first let us discuss how one can find out tangential acceleration is there. So let us discuss first tangential acceleration. Tangential acceleration. So this acceleration is due to change of magnitude of velocity of a particle. So that is, this is only when the kinetic energy of a particle changes, right? So we can say when the kinetic energy of a particle changes, then only when we discuss tangential acceleration. For example, suppose if you drop a particle, then it is just coming in the downward direction. Then in this case, its direction is not changing, only magnitude keep on changing is there. So particle has only tangential acceleration. Or we can say, so at this point, we can write AT d mod v by dt. Let me repeat here, when you write dv by dt, rate of change of velocity, this is your net acceleration. But this is your tangential acceleration, rate of change of speed of the particle, magnitude of v I have written at this point is there. Or we can say it is the component of acceleration in the direction of velocity. So we can write also AT is equal to A dot V upon, in the direction of V is there, so that is mod V. So both are, that is, in this case you can differentiate, or in this case you can take the component is there. See, the main function of tangential acceleration is to change the magnitude of a particle is there. That is, you are changing the kinetic energy. When kinetic energy is not changing, it's what? Tangential acceleration is zero. Right? And then we are coming for normal acceleration. That is, normal acceleration is there. So normal acceleration. So it is the component of acceleration normal to velocity. The main function of normal acceleration to change the direction. So whenever the direction changes, we have normal acceleration or centripetal acceleration or radial acceleration, all are the name are there. So when the direction of a particle changes, we talk about normal acceleration. So normal acceleration. So we can say A is AT plus AN. So net acceleration is AT square plus AN square. So this is the net acceleration. So inside it can have tangential as well as what? Normal acceleration. For example, let the velocity of a particle is given by v is equal to 2I plus tj, right? So see, in this case, at different time it has different velocity, so the magnitude is also changing, or as well as since its x component is constant but y component is keep on increasing, so the direction of v is also changing. So this particle has tangential acceleration as well as normal acceleration. So suppose someone will ask you what is the value of AT and AN at t is equal to 2 seconds. So first, if I want to calculate AT is nothing but it is d by dt of mod v. So this is d by dt of 4 plus t square. So this is 1 by 2 4 plus t square root, and then it is 0 plus 2t. So this gets cancelled. So t upon root under 4 plus t square. That AT at t is equal to 2 seconds. I need at 2 seconds. So this is 2 upon 4 plus 2 square. So this is 2 by root 8. So this is 2 by 2 root 2. So 1 by root 2 meter per second square. Now I want to calculate what is AN for this. So you can calculate AN. Since direction is also changing, so we can have AN is also there. So we can calculate AN. So since A square is equal to AT square plus AN square. So let us calculate first A for this particle. So V is given as 2I plus Tj and net acceleration dV by dt 0 plus 1j. So the net acceleration is 1 meter per second square. So therefore from here AN is A square minus AT square. So this is 1 minus, at this point 1 by 2. So this is half, that is 1 by root 2 meter per second square. So you'll have answer. A is 1 meter per second square. AT is 1 by root 2 meter per second square. And AN is 1 by root 2 meter per second square. So let me try to tell to you, net acceleration is different, tangential acceleration is different, and normal acceleration is different. So whenever you have any question, then think positively. And what is in the question? He's asking you acceleration or tangential acceleration or normal acceleration. Okay, thank you.